Right, this is rough and ready, so you know it needs tidying up. Actually, there's a new box lid. This is the old box lid I'm using at the moment. Let's try and get this stepper in. Can get that in at the same time. I've only got turning one turn every 15 seconds. It is timed here. I can manually override it with the push buttons, and the LED lights light up when I do push the buttons. So let's get the wiring. This is 12 volts from this power supply here. You see the amps there. Well, claimed ampage. Not too reliable, these power supplies I've had, but this has done me quite well. I can't complain about it really too much, except that it's a bit hard to see the fine, which knob is fine and which is like coarse as a fine and coarse, and it's a bit hard to see the words when you're looking down a little bit from up here. Let's see, I've got it normally, I'll show you just now, that's on 0. I've been soldering, had some problems with the switches and the LEDs on this thing here. See, it's only taking an ampage when it's actually turning. Now normally get this wire out the way if I can. That's the 12 volts going in here. I've also got the Arduino plugged in into normal USB. So it's like got two power supplies. This powering the stepper controller here, and this one's powering the Arduino. So just 12 volts going in there, as you've seen the ampage. And you can put 4 steppers on here. Actually, you can wire up more external. You'll have to forgive these because I did some joins in these cables, because I did have it to other controllers and they just kept overheating. Now that is cool, but one reason I've normally just say put like a jumper on this EN ground pins going across like that way, and it needs the enable pin setting to low, okay, to get it to turn on. Yes, that's counterintuitive, I know, but that's what you have to do. You have to set it to low, but you can do that in the Arduino code, which is what I'm doing, so I don't need the jumper pin on here. I'll just show you the stepper. This is NEMA 17. I'll put this bit of felt tip mark on, and this can, because I don't have any power on while it's paused here, it can be turned, but once it starts turning, I cannot, I can't control that. Just a not, and that is cold. It's been going, well, it's very, very slightly warm, very slightly, not even lukewarm, I would say. You'll probably hear it turning there. As I say, one turn there. Let me show you it going in reverse. A bit awkward for me because I'm trying to see, and that's going one turn reverse. That's on the timer going forward there, because I've only got the timer set to 15 seconds. See, press it twice and then forward. I can go forward a pulse, well, a turn, well, it's all controllable, and then it's doing a time turn on top of that. Okay, so this is, I can't remember, this is one of these basic early sort of step drivers. You can use other drivers in here, but this is okay, it's cool. Notice where the potentiometer, you can adjust that. I turned it quite very low down, as low as I dare go. Use a multimeter trick. There's plenty of videos online to show you that, so try and put some stills of this as well. So these are the pins. Sometimes these wires, so just under this board is the Arduino there. Okay, I think you can use other Arduinos with this board. So you can see the wires there. So there's two wires, there's a green and red LED, there's a sort of feed and unfeed, I'm going to call it, because this is to feed liquid. When I get a peristaltic pump to go with this, should be coming in a few days, to feed liquid for fish, baby fish. That's what I'm hoping. This is an ongoing thing I've been working on. Had this sort of syringe mechanism here with one of these steppers there. I worked reasonably well, but I had an awful lot of problem with the liquid adhesion, water adhesion, that would leave a drop on the end of a needle. Now I need to test this a bit more. This is supposed to be a bit like a tap. You know how a tap drips? And if you notice a tap dripping, it drips, seems to me to be a definite drop. Okay, and that's upside down, but we're working on this at the moment, so let's show you this again. I'm trying to show you different angles. I'll try and put some stills on, so if this is going upside down. So I'll show you the code that I'm using at the moment. Now this still might need tweaking, like adjusting and such like. It's a mess because I've been having to hack. One problem with these boards is the Arduino and quite a few of the other boards have female headers in, but this all has male like headers on. Well, apart from the steppers. The steppers are female, but all the other pins are male. So I've had to like swap plugs over and muck about just to get the working, but it's working at the moment. It's come out a bit, so you'll have to forgive this. Stop yakking a bit. So that's a green LED with a green button I can press to go forward. Now, as I say, unfeed, so that's to like rewind the stepper. And this has a lot of power. As I say, the way I've got it at the moment without this on, I've only got it to turn, like enable the steppers when it's about to move, when the step is about to move. And that saves it from getting hot, because I was using this earlier on and it was getting pretty hot even on low amperage. Now these can get very hot without damaging. I've heard of 120 degrees without damaging them, but I didn't want that. So what I've done, I've removed it. That's if you've got that jumper on, it's going to hold the holding power on all the time. See, I can turn that until it starts turning. Once it gets under power though, I can't stop that. I don't want to lose my wires out of here. I've spent 3 days putting them all together. But see, if you've got that on, or you can have the enabled all the time, it gets pretty warm because it's using quite a bit of like amperage in the coils to keep the holding power on the stepper. But what I do in the enable and disable to a certain extent commands in the software, in the Arduino software, is I tell it to turn this enable off, and that it doesn't lose position. I keep a track on the position anyway, but it doesn't lose, you know, it just picks back up when it gets in the next pulse. It turns it back on and then off as soon as it's finished doing the turn. So it turns it on now, turns it off now, and then it's free to move. But that saves an awful lot of amperage. See, the amperage has gone down to 0 there, and it's about 3/4 of an amp there. I did set it, when I turned it down, I did go on adjustment potentiometer there. Plenty of videos online showing you how to do that, so I won't repeat them. I did turn it up a little bit because I wanted it to be pretty solid like the motor. Right, I think that's enough. I'll try and get some stills on here, especially of these pins. It's hard to get this into focus, sorry, but the stills should be better, I hope. Right, I'll show you the screen, the code I'm using at the moment. Now this does feed to a certain, it does about 120 turns. Well, you know, how far it turns is all controllable. I think you can even adjust the speed. This is full step, and I think that's the fastest it can go actually. I'm a bit unsure about that because I've been mucking about with the code left and right and I've lost track a bit, but it's working. This is an old timing belt pulley on here. I'll just let you watch it a bit more. I can tell you that is cool. It's not hot. I put on this to stop it vibrating. I'll show you the vibrations if I can. Well, you can hear the vibration there. Now this is using acceleration and de-acceleration. I don't know if you'll notice that. On short distances it's pretty pointless, but starts slow, then it speeds up, then it'll slow down a little bit there when it finishes off, using the Arduino library for that. Just want to try and show you. So that's why I've got this bit of cloth, and it helps stop this stepper from like vibrating off this computer desk I've got here. So waffle, 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 waffle. I'll just show you the back of this. So 2 LEDs in these tubes and 2 like button switches there. Let's say it's a bit of a nightmare, but it works. So now I've got on this just a bit of like microfiber cloth here. You see the difference there? That dampens it and it stops it like shaking off this computer desk. Okay, enough of that waffle. I'll show you the code. I've just, well, what I do, I ask it to go forward timed, and then when it reaches the limit I ask it to rewind all the way back. that was for use with this syringe method I was using. It's not probably going to be used so much when I get a peristaltic pump set up, where I have to do some testing on that as well. But I noticed just there that it didn't go back as far as it should. So there's a bug in the code that needs sorting out. But I'm going to upload the code as it is now with that bug in. I mean, it doesn't hurt anything, it just needs like tweaking in a way. You might hear you can hear the fan on the PSU power supply thing I've got there coming on when it does it, but also hear the motor in the background. So here's the code, and it's using Arduino Uno, CNC Shield version 3, and I will be adding a peristaltic pump to this. So I'd like to thank all the people who've put code online and such like. I've copied some code off from various places. There's no one thing I can really say. So those are all comments up there. So I've got accelerated stepper, and I'm using no delay. That is what I term as a magic code for doing delays in this, because I will be wanting a 4-hour delay, because that's how often you have to feed baby fries liquid, like liquefy I think it's called. And instead of standing there, you know, every 4 hours or waking up every 4 hours, I'm hoping this will do it automatically. So there's the timer, and that's the time. I've got this temporary time to test it to 15 seconds. That's creating an instant of the no delay. Because I've tried interrupts, I was trying interrupts and trying, I do have it in here somewhere. I know I've got it written down here. Interrupts didn't work, timer did not work, delay, I couldn't do it long enough. I think that's why I didn't want to use that. So first of all, we tell it the stepper, well, the pins for the shield, and there's your accelerated stepper there. I think the number 1 here is the type of stepper. Well, in this case it's the shield that we're working on, and then we've got various pin numbers on the shield. I'm doing 1 drop, that's 110, 200, 200 at 1.8 degrees, 360, full step. So there are jumper pins on this like board that you can select, and that's how many drops I'm going to ask for, 120. That'll be that. All this needs adjusting actually. This is built on my other code. So I enable the pin, enable pin output. So you need this big code in here for this to work. And then we get in a loop, start with a stop, and then we setting up the LEDs and such like, and we're reading the values on the buttons. I found that if I'd used the serial port here, that it really slows it down. Sometimes it's so slow that it's impossible to really, well, you know, it makes it awkward to use. And see, that's got an N in front of there because that's a no delay command. It keeps on looping until this is true, and then it'll jump to this feed 1 drop pulses. I'll go down there because a lot of this is, so it gets in this feed 1 drop pulses. Again, I've got some comments there to help me track down where the errors were in the code, where the bugs were. But you see here, right at the beginning, somewhere, there we are, enable stepper pin false, and actually that's turning on the stepper. When you say false in this case, it's turning on the stepper. Okay, so turns on the stepper, then we sort of set up the move command, then we move to that position, then we turn the stepper back off to save power and stop it overheating, then we turn the LED off. Okay, the unfeed at the moment, I'm not doing, you do have a direction thing in this, on this board that you can select. Let's go back up here. So you've got a direction pin, and you can tell it which direction you want to move in. But I'm just doing a minus from its position it's in. So you see it grabs the position now. There's a position now. This is all part of the accelerated code, whatever it is, in that library. It gets a position now. There's a position now there, and it adds one drop pulses on top of that, and then it moves to that position. Okay, there's a few other bits of code in here. Reset stepper, and flash the LEDs if I want to flash the LEDs, which I sometimes do if when it reaches a limit of, it's only got a software limit on here. So I'm just giving you a quick look. What I mainly wanted to show you is the turning on and off the stepper. When it gets in here, there we are. Digital write that pin false, and then when it's finished doing the movement, set it to true. So false is to turn it on, and true is to turn it off. Also remember that with the LEDs, they tend to be one of these things because they're on limit switches and God knows what, I don't know, but tend to be a bit back to front the way they do those as well. I've got a while loop in there just to keep going forever. I probably don't need that, but I'm going to leave that in there. I can take this, I can comment that out actually. Comment that out. Again, that's just so I can track which buttons are being pressed. I had an awful lot of problems. Right, that's enough of that. I don't know if YouTube will let me put all this code on there. We'll try to upload this as it is now. Now remember, this is a bit basic, but it's got LEDs on, it's got a couple of push buttons on, and obviously working the stepper. Right, that's these are all the pins. This helped me quite a bit to work out which pins I needed to connect up. One issue I found is because I have, like if it's at the limits it's going to be flashing, and because we're in a loop here, the Arduino famous loop, I did have a while, another loop here, while loop, as you might have seen earlier, but I found this other command which is better, and it's exit bracket 0 bracket, and you do need that. I've been told, informed in a way that you do need that 0 in there. this is not shown in Arduino website, this exit command, so as I know that's what I'm read up on the internet. But this stops the program looping, which stops the flashing limit sort of LED from stops there, because it'd be at the limit because we moved here to the start position. This was for my syringe, which I showed you earlier. It's probably not needed in this peristaltic pump. Well, I'm going to leave it in the code for now. When it does move to that limit, it gets a signal that's at the limit, so it flashes the LED, but keeps on flashing when if you don't have a while loop or something to stop the program continuing on, because it'll just come round and it'll say it's at the limit, just come round and say it's at the limit, so to speak. But this exits this loop. There might be some subtle changes. I'm going to put this in the comments actually. That's a timed stepper movement with like an override of the push buttons and LEDs basically. Okay.